Whoa, do you see those cliffs? Well, I've actually been on the edge of those cliffs. Those are called the Cliffs of Moher, and they're in Ireland. They're one of the awesome sights to see in Ireland. I was very fortunate enough to be able to go there and then see that. Pretty awesome. If you ever go to Ireland, definitely go check out the Cliffs of Moher. But anyway, that's going to be my theme for today. Section 7 in Chapter 8 is about factoring polynomials, special cases of polynomials. We really talked about factoring polynomials yesterday or last time in Section 6 and the three different ways, particularly the distributive property way and the bottoms-up method. What we're going to do today in this lesson is talk about factoring special cases. So that's where our goals come in here, our two goals. So we're going to factor perfect square trinomials, and we're also going to factor the difference of two squares. So what those two things are right here. So um, perfect square trinomial is any trinomial of the form a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared, where we have perfect squares at the end. And then the difference of two squares um, is an expression in the form a squared minus b squared. So that's what we're going to talk about. Difference is subtraction, and two squares would be the a squared and the b squared. And we're going to factor them to be a plus b and a minus b. So that kind of gives away part of what we're doing already today. So quick review. We talked about back in, I don't know, section 4, okay, section 4 here of this chapter, when we found special products, so multiplied special things, like the sum of a square, or the square of a sum, sorry. So like when you had 2x plus 3 squared, so that's just writing out 2x plus 3 times 2x plus 3. It's not, remember, it's not just distributing this to the two things in there. It's not squaring the 2x and it's not squaring the 3, because that would leave out the outside and the inside for FOIL. It's 2x plus 3 times 2x plus 3, which we find out is the first two, so that's 4x squared. The back ones is 9 at the end. And then the middle is going to be the first times the second, times 2. So we have, because they'll both be 6x in these middle terms. We're going to kind of go backwards from that. We're going to take difference of two squares. Sorry, not difference. We're going to do our first one, which is factoring perfect square trinomials, which is like that right there. So let's first talk about how we can tell if a trinomial is a perfect square, all right? Because if it is a perfect square, there's a pretty easy way to go about it. All right, you can always do one of the other methods we talked about, but there's an easier way if you can recognize that they're perfect squares. So, question 1, is the first term a perfect square? If it is, all right, let's move on. Question 2, is the last term a perfect square? If it is, that's good. And then finally, is the middle term the product of the square roots of the first and the third, and 2. So multiplying those by each other and 2. If it is, then it's a perfect square trinomial. So if we have that as a case, here's how we factor a perfect square trinomial. First thing we do is find the square root of the first term and make it the first term in each of the parentheses. So we set up our parentheses, all right? And that's going to be the first term in both of those. Then we're going to find the square root of the last term and make it the second term in each of the parentheses. And then the sign between will be the same sign as the middle term. And that is it. So let's take a look here. We have 9x squared plus 30x plus 25. So what we're going to do is we're going to look at this. We're going to see this is a perfect square, this is a perfect square. So I'm going to set up my parentheses. The square root of 9x squared is 3x. So I have 3x times 3x. That'll give me 9x squared. Okay, that's our first term. This right here is a plus, so we're going to use plus for both of them. Alright, and then the square root of 25 is 5. So we have the square root of 9x squared is 3x. Square root of 25 is 5. So we're going to put 5 in for the second term. And guess what? We just factored that trinomial. It's that easy. You can double check. You can go back and say, alright, I'm going to FOIL it. First, it's going to be 9x squared. Outsides, we get 15x, and then the insides we have 15x. That gets us 30x total. And the last will get us 25. All right, let's do another example before we move on. We have 4x squared plus 36x plus 81. Okay, we look at this and we see this is the perfect square, this is the perfect square, and then the square root of both of those, so 2x and 9, you multiply them together, and we get 36x if we multiply it by 2. So that's the last part, we have to multiply it by 2. So this is a perfect square trinomial. So let's do that right there. Let's set it up. Square root of 4x squared would be 2x, because 2x times 2x equals 4x squared. We have a plus sign, so we're going to use a plus sign in here. And then finally, the square root of 81 is 9, so we put in our 9. And again, we can check it by foiling. And we do get 4x squared plus 36x plus 81. Woohoo! Perfect square trinomials are great because they're that quick. So I'm going to give you two of them to try. So pause it right now. Try these two. We have x squared plus 6x plus 9. So that would be a perfect square trinomial, or you can just use the look for the target numbers. And then what is the factored form of 12x squared plus 3? I'm going to give you a hint. Factor out the greatest common factor first. There is something that you can factor out first, and then you can do, I believe you'll be able to do the difference of squares. Alright, so I started with the first one. I double checked to make sure it's a perfect square trinomial. X squared, the square root of x squared is x. Square root of 9 is 3. And then I multiply those together times 2, I get 6x. So it is a perfect square trinomial. So I can take that first term, that square root of x squared, so that x, put that the first term in both of them, put the 3 as the second term in both of them, and then the sign here told me that's plus in the middle. So it works out. All right, and the second one, you have to factor out a 3 first. So the greatest common factor there would be 3. So if I factor out 3, then this is what I'm left with. And then that trinomial is a perfect square trinomial. I checked it right here. All right, so then I bring it over here, and I found 2x is going to be the first term for both. 1 is going to be the second term for both. And then we have a plus sign. But we can't forget this 3 in the front, because that's still one of the factors that we factored out right away. All right, so that is working with perfect square trinomials. Again, quicker if you know it's a perfect square trinomial using this method. Now, the second special case is factoring the difference of two squares. So, and this is actually going to be very simple too. The difference of two squares would be if we had like an a squared plus minus a b squared. It has to be subtraction. That's part of the difference. All right, and every time you factor, it's going to be whatever the a minus the b, or a plus the b times a minus the b. So here's an example. We have x squared minus 64. We know that that would be x squared minus 8 squared. So we factor that, we do x minus 8 times x plus 8. Okay, this one too. We have perfect square, perfect square. This would be like 5x squared minus 6 squared. So our factors are 5x and 6. So we have 5x plus 6 times 5x minus 6. So let's put that into words for some steps here. All right, well, here's some indicators that a difference of squares can be used. A polynomial contains a difference of two terms. That's the first thing, and both terms are perfect squares. Okay, if we got that, then let's follow these procedures. Put the terms in descending order. Hopefully they're already in descending order. Factor out the greatest common factor if there is one. We always got to make sure we do that. If the polynomial contains a difference of perfect squares, then the difference of squares should be used. Again, that's not really a step, but we have to first determine if they are a difference of squares. All right, so find the square root of the first term and the square root of the second term. Put these in parentheses. One parentheses should be the sum of the two terms, and the other should be the difference. And that's simply it. Remember, a perfect square is a number whose square root is a whole number. So we're not using, if you're dealing with numbers, these are all like the common perfect squares. Because the square root of 1 is 1, square root of 4 is 2, all the way up to the square root of 225 would be 15, I believe. So let's use those, and let's do a couple examples. First example I've got here for you. 16y squared minus 81z squared. So this would be like saying 4y, and we're squaring that, because that would be 16 and y squared. And it's a difference. And then we have this one right here would be like 9z, and squaring that. So there we got the difference of two squares. So our factors are 4y and 9z. All right, so we can do 4, whoops, I believe I have it broken down here for you already, but I just did. All right, so we got 4y plus 9z and 4y minus 9z. And that would be that first example. Okay, remember one has to be a sum, and one has to be a difference when we are having our two binomials. All right, second example, 3b cubed minus 27b. So we've got a difference here, but they're not perfect squares. So here's where we got to look and remember our first step. Can you factor out a greatest common factor? And yes, you can factor out 3 from both of them. So if it's a 3, then we just have b cubed minus, oh, we can factor out a 3b. There we go. So then it's b squared minus 9. And these are perfect squares. We'd have, this would be 3 squared. So our two terms, when we're factoring that binomial, is b and 3. One has to have an addition sign, one has to have a subtraction sign. Again, we pulled out that 3b right away. So we have 3b times b plus 3 and times b minus 3. Okay? I'm going to have you try those. Make sure they're perfect squares first. We've got two of them. And, or difference of squares first, and then go ahead and try them. So if you want to pause it right now, try them out. I will have them shown in just a second. All right. So the difference of squares here would be v would be squared and 10 would be squared. So I rewrote it like that. So our two parts are v and 10. So we got v plus 10 times v minus 10, and that'll get us to that result of v squared minus 100. Second one, we had a first factor out the greatest common factor. There's a 12 you can pull out of both of those, so I pulled that 12 out right here. And then I'm left with x squared minus 4, and I rewrote that as minus 2 squared. So I have the common, or sorry, I have the perfect squares. We've got x and 2. So we have 12 out in front times x plus 2 times x minus 2. And again, you can factor that out. You can multiply that out, and you'll get back to 12 x squared minus 48. So that's the last example. Those are the two special cases that we wanted to talk about. Difference of squares and perfect square trinomials. So my closing question for you here is, find the error. It says Manuel and Jessica are factoring 64x squared plus 16y squared. And they both did it two different ways. Here's Manuel's way, and here's Jessica's way. Who is correct? And explain your reasoning. That brings us back to our goals. So our goals are to factor perfect square trinomials and to factor difference of two squares. I think we did that. I hope you learned something. I hope you got something out of that. I hope you're able to figure those out. If you see those special cases, you're able to now factor them. All right? Makes your life a little bit easier. So going back to the closing question, if you look at it, Manuel factored out 16, and so did Jessica. Then Jessica took it another step and did the difference of squares. There definitely are squares here, but here's the problem. There's not a difference. Has to be subtraction there. Okay? Has to be subtraction. So that's why Jessica's is actually not correct. Emmanuel did it correctly. All right? There you go. Have a great rest of your day. That was factoring special cases.